Hi, thank you guys. Well, it's our first time here in Amsterdam, so we are very happy to be in this country, and this conference is great. She's Sheila with me.
Hi everyone, thank you
Hi.
for coming.
I am Claudio. Well, we are from Buenos Aires, from Argentina. We work for Telefónica in the 11 paths. It's the unit of cybersecurity of Telefónica. And we are from Argentina, I say before, and I suppose that most of you knows about Argentina. Argentina have beautiful place. We have great soccer players. We have a queen here. We have a pope. But the best important thing is that we have the asado argentino. So if you go to Argentina, you have to test it. Yeah. We are here to talk about cars, about hacking cars, and a specific form of hacking cars. For doing that, most of people ask us about when we start working with cars or testing cars. We work from some years with cars from different areas in cars, and we work in security, in different things, security about web application or mobile phones or other things. Yeah, but in cars we have working some years in doing some reverse or doing some research about the engine, about the odometer, about the speedometer, about anything, anything of things. And the first talk that we have, we did was in the Coparty 2 years before, and this talk was about backdooring the canvas of the car. And that is the starting, or the beginning of this talk. Yeah. Some people ask us about why we are doing research in this area. And the real question is, why not? Huh? It's because it's funny. It's funny because I love that, because it's an own car, so I want to test my car and modify my car. And so we try to do some different things in our own cars. But for 2 years ago or more, I don't know, I don't remember, there is a lot of talks about car hacking, and that's talk, for example, that Charlie Miller and Chris Barasek, they're excellent talk, excellent, great investigation, but they speak always about connected cars. Yeah, so the connected cars are great, but this type of car, they are not present in our country. This is a big problem. In our country, we have cars from 19th or even more newer, but the problem that if you buy a newer car here, I am sure that have this type of technology, GPS or Wi-Fi or SIM connector, but if you buy the same car in Argentina, there is anything of this present. So we try to do some research, thinking about how can we backdoor a car, or how can we control a car that is not connected by default. Yeah. So many people ask us if it is possible to break our own car, and the answer is yes. Yes. For example, in this case, you will see that I start the engine of the car. Yeah. I don't touch anything, but I just connect a simple device to read the CAN message, and the car just stop function. Yeah. Right. Okay. Stop function. This is possible, but this is common. No, not really. Not this very common. But if you have this problem, you don't have this button. Yeah. In the car, in any part, but you can do this one. You can disconnect the battery, wait some minutes, and connect again, and you can start again. Yeah, it's not a very difficult problem, but it is possible that when you start injecting frames, not reading with this car, when you start injecting frames, maybe the engine motor, is oh, se me fue la palabra. The engine, sorry. The engine is stopped because we start the protection, the security protection of the engine, and the engine stopped working. I have that problem with a car of my friend, and the car doesn't start for 2 weeks. Yeah, it's not my friend now. But well, in this case, the battery is not the solution. You have to do some investigation. Do you need some tools to reestablish the protection of the engine? Or you can pay some self-service to do that, but it's not so funny. Yeah? If you have to pay, it's not funny. Another thing that we can say before starting is that you have to be very careful when playing with cars, yeah, because it's not the same that a computer. The cars, if you need that was in starting and with the start machine, with the start engine, so maybe it's dangerous for you or for the people around you, or for your house, or for your dog. So you have to be careful. You have to be sure that nobody is in front of your car, nobody is backing your car. You have to take any type of care, because doesn't matter how trained or how well trained are you. Accidents occur. Yeah, accident happens. For example, this one. This is not me. This is a internet video, YouTube video. This is not good. This is not good. All right. For start working with the CAN of your car, you have to know some important things. The first one is that in your car, if your car is newer, from 2006 till now, you have this type of connector on your car. Do you see this? Yeah? This connector is the ODB2 ports. This connector is used for the diagnostic. Yes, when you have an issue with your car or some type of problem, you can connect some device in this port, and with these 2 pins, the software of your vendor can do some diagnostic of the issue of the cars, yeah, using these protocols. I'm sorry, this one and this one, yes, pin 7 and pin 15. And also another vendors use this other protocol with pin 2 and pin 10. But for us, it's important these pins, pin 6 and pin 14. This is the pin that we use for CAN investigation. If you have this connector, that doesn't mean that you have CAN in your car, yeah? Sorry, you have CAN in your car, but not exposed. Yeah? So if you have these pins exposed, you can connect some device and read the information of the CAN. The CAN is the network, is the protocol used in the core of the mobile, of the auto, of your car. Yes. So, what's about the CAN bus?
Well, when we start learning about CAN, the first thing we will see is the CAN bus. That's why the CAN network is based on a bus topology. So each node might be a sensor or a vehicle EQ, and the information transmitted on the bus can be used by several nodes at the same time. So, since CAN was developed for using in automotive environments where there is a lot of noise, it uses a system known as differential voltage that allows it to gain immunity against interference. In this system, the transmitter transmits a signal in duplicate, one with positive value and the other one with negative value. These are the CAN high and CAN low signals. And if the receiver receives 2 signals that are not equal, it discards it, assuming that it's noise on the bus. Yep. So moreover, CAN protocol has another thing known as inverted logic, where we have a dominant state, which is 0, and a recessive state, which is 1. And this influences a little bit on the frames format. Here we have a standard CAN frame. The green part is the arbitration field that contains the frame's ID. Because of this inverted logic, those IDs with mostly zeros will have the higher priority on the canvas. That's why, for example, those CAN frames related to the engine has the lowest ID, so the higher priority on the canvas. So after we have the data length in yellow and the data itself that can contain a maximum of 8 bytes. So as we can observe, there are not destination or source addresses, neither destination or source ports like protocols we know better, such as TCP/IP. So a CAN node has to check the arbitration field to know if it should take the frame's data. So that's what a CAN frame looks like. And we have to know that a CAN frame does not indicate anywhere what kind of information is carried. For example, a CAN frame carrying information about the RPM does not indicate anywhere that its information is about RPM. So to find out what kind of data each frame is carrying, we have to do a reversing process. For that reversing process, there are several different tools. For example, this is an oscilloscope, and it's the lower level tool that we can find to analyze CAN signals. In our case, we had a CAN module that allows us to see the hexadecimal representation of such signals. But as we can observe, the CAN frames are passing very fast on the screen. So an oscilloscope is useful to analyze the signals, but not much to do card hacking itself. To do card hacking are more useful higher level tools. For example, the canvas analyzer from Microchip. Here we can see the CAN frames in a nice way, and we can analyze them more easily. However, the great question is, how can we find the CAN frame that we are looking for? For example, if we are looking for a CAN frame associated with the headlights or the RPM or whatever, how can we find that specific CAN frame? So the first thing we have to do is to choose a tool. Nowadays, there are several tools to analyze CAN signals in a higher level. For example, CAN Spy, CAN Analyzer from Microchip, or even we can use Socket CAN together with an open hardware tool. So we have to choose a tool that we like, and after that, we have to start with the reversing process. For example, here we have a CAN frame of a pickup, and when the headlights are off, we can see that CAN frame. If we turn on the low headlights, we can observe that the first byte is changing its value from 40 to 46. And if we turn on the high headlights, we can observe that the second byte is changing its value to 1e. So we have to spend so many hours and observe the behavior of the CAN frames. So we had to get inside the car, spend so many hours inside the car, and try to perform certain actions, for example, turn on and turn off the headlights or start the machine, etc., and observe what CAN frame is changing its value of their bytes. So that is the way to find the CAN frame that we are looking for. When we start...
That is important in the slide before. Yep. That is important to know that if you have two pickups from the same vendor, so the same brand, maybe the CAN measures or the CAN frames are different. Yeah, so it's not so easy to identify the correct frame for every car.
Exactly. It's changing depending the model, the share, etc., etc. Also.
The country.
Yeah. Okay, and when we start, we began using the canvas analyzer from Microchip, and this is an sniffer. So these tools usually allow us to injecting cam frames on the canvas, but usually the frequency with which these tools makes that transmission may not be fast enough for the canvas. That's when this happens. So each node is sending its current status constantly. So in that case, the light module is sending that the current light status is off, while we are injecting every 100 milliseconds. No, they are on. So that's what produced the flicker effect.
Okay. No, espérame un segundo. Dame, ¿dónde lo puse yo olvido? In this case, we have this car. This is a VW car. So many people say, okay, it's easy if I turn off the lights to identify the correct message with this type of tool or with another tool, for example, car loop. And the correct answer is not. It's not easy because when you start the light, even in this type of car that is a mechanic switch for starting the light, you will see this type of frame, this type of movement. There are so many frames, not just one frame changing. Why is that? Because when you start when you put on the light switch, you will brighten the control panel, the radio, another things on other parts of the car, and all these messages are seen or are captured with this tool or this type of tool. Some of you can think that we can do some special script to identify the changing. Yeah, that's true. That's true in this type of car. But if you use a newer car, for example, an Honda Civic from the last year, yeah, and put the key in the contact mode, you will see this one in the control panel. And you will have one message for every light. So it is impossible. It's like a Matrix movie. Yeah? It's impossible to read all this type of information. So this is the starting information for you. Our project was about backdooring the CAN, not about just CAN, just knowing CAN. So we start working in the concept of a backdoor, but we have in mind that we don't want to work with a Raspberry Pi, even with an Arduino. We want to develop our own hardware, and we want to work in a real remote scenario. For example, we see a lot of paper or a lot of talks working or talking about remote backdooring for remote connection with a car, but they use Bluetooth. Bluetooth have a very short distance. So we want to work in a different model. So we developed this first version of the Vito. That is not one, yeah?
When we started with this project, we made a simple CAN frame injector. Yeah. We developed the firmware in assembly, so it's worked fast, or at least fast enough for the cameras, avoiding that what we saw in the previous video. So we use a PIC 2585, so, and a transceiver to convert the CAN high and CAN low signals. But it's simple. But after that, the malicious ideas come in, and we thought, how could we control it in a remote way? That's when we added a SYN800 module, so that we could inject the CAN frames through SMS command from any geographical point. And that was the first version of the Vito.
This one.
Yeah, it's this one. It's little than the connector.
Yeah.
But that first version had a little problem. When we wanted to inject a CAN frame, we had to set up the CAN frame by hand in the firmware. That means that a little error in a 0 or 1, it wasn't work. We had to recompile it again and again, so it was awful. So we thought that it would be nice to set up the CAN frames through a USB interface using a desktop software, etc. So for that, we started making the second version of the vision, and we made some changes in the hardware. We added the USB interface, and we added a switch. The switch allows us to toggle between two modes. We have the hacking mode. The hacking mode is when we are connecting the video to the car. And the programming mode, when we are connecting the video to the USB in the computer and we are programming the CAN frames, the advanced features, the tile number filter, and some other things that Claudio will show you in brief. So with this improvement in the hardware, we have to improve the firmware as well. Now we have different subroutines to detect if we are receiving data from the computer or from the syntax handler module, and what SMS command we have received, what CAN frame we have to inject, what tile number was sent to the SMS command, making the injection, so blah, blah. Actually, we have 2,150 lines, and we don't know who wants to keep in on this code. So that was the second version of the vision. However, for this conference, we are releasing the third version of the vision. We have made some improvements in the hardware. For example, we are using the mini USB, and we have added new features in the firmware as well. So, by the way, we have just 5 divisions with us today that we are selling. So, if you want to get one of them, you can contact us after we finish our talk. So, that was the evolution of our project, the first version, the second version, and the third version.
This is the beautiful version.
Yeah. Yes. Well, we were working in that along 2 years. So.
Well, at this point in the first version, we have to do some configuration with the microcontroller itself. But in the second version, we stopped thinking about how can anyone could configure the hardware, the video. So we create a software, an interface to work with this. And this is a very simple software. You don't need to know anything about programming. Just you have to know the correct frames and put it in order, no? The ID frames, the length, every data. And you have to say which is the message that you will send to activate that specific frame. Yeah? For example, if you send this message to the video using SMS, you will start injecting this frame to the car. When you send a stop message, the injecting will stop. It's simple. No, you don't need anything. So this is our design, and when we started working with this design, we think that it's better if we can add some extra features. So in that extra feature, we add a filter for your phone. So if you connect the video in your car, Sheila can send messages to your car. So you can identify yourself, your own phone number, and only you will control in your car. Yeah. Another feature is, for example, this one, that you can set up the attack payload that you want to run automatically when the car is proximate to this GPS location. So when the car the driver is for this specific location in any city, you don't have to send the message, an SMS. You use the previously defined frame. For example, number 3, in this case, this one. Yeah? We do the same, but without the latitude and longitude, we use the same using a specific detected frame into the car. So if you are driving and you start, for example, the air condition and you know the specific frame of the air condition, when the person starts the air condition, we can activate the brake of the car. Yeah, so everything. What do you want? Yeah. And for this version, for this conference, we add another feature that we named Kileku.
A little bit dangerous, I guess.
Yeah.
I don't.
This is just for fun and for testing the.
Who wants to test it?
Okay. With your cam. You can send the lowest message, frame message to the car, to the ECU. So the ECU will attend that message every time, and doesn't execute any other message real in the car. Yeah? So the ECU normally stop function. Yeah.
So we are using a CAN frame with the lowest ID. So we are taking the priority, the higher priority on the bus, and blocking the other nodes.
So, what more? At this point, we have the hardware and we have the software, but most of people have problem with reading the CAN, with find the correct CAN that they have to insert. So we start working in another project. Yeah, so many projects. We start working in another project that we call OpenCANDB. Yeah, it's OpenCANDB. It's another database online when you can add the frame that you find in your car and share with another people in another place of the world. Yeah? So it's very simple. You say the correct frame that you found with vector is modifying this specific frame with model of your car, with year of your car, and with country. Yeah. So another person in another part of the world can download this frame and check if it is correct. Yeah. If you don't have the correct module because we don't put it in the database, you can add a new model into a specific run, or maybe you can add a specific vector that we don't know. So it's everything to check. Which is the most common problem that some people send message like this, that please add this version of this model or this brand that because there is not present in your database. We add this brand and nobody charge any frame in that database. So this is a big problem. But this project is open source. You can try to find a new message in your car and please add to this one. So at this point we have 3 projects open, free. Yeah, it's the hardware, the software, and the database. So what can to do is just fun. Yeah. So for example, if you want to use the software, it's very easy. Let me show you. 1 second. If you want to program in the Vitro, you have to connect this one to the computer, like this. Put the switch in programming mode. Yeah. The lights start blinking. The computer fails. Okay. Connect to it. All right. And just run the program. And it's, well, sorry. 1, 2, 3, 4. Okay, this is the program. So if you know the correct ID, you just put it here, or maybe you can use a JSON template. With all the message. First, connect the device. Yeah, it's connected. It's beautiful, yeah? Put your number. It's not my number. Huh? And just write the code. And that's all. It's ready. So disconnect here, put the switch in mode hacking, and plug in this in the car. And that's all that you know that you need to know. Yeah? It's very easy to use. And we can see in this example, because we can try the car here. In this example, you can see that the light, the brake light is off, and nobody is in the car. Nobody is in the car. I send a message to the bicho for starting the light. And you will see that the light is brighting. Okay? And then, thank you. I send a new message, starting the accelerator, the gas pedal, yeah? And you will see that it's stopped, and now it's running. Yeah? It's very funny. So, it is possible to do a real backdoor in a real scenario? Yes, it is. If you use some social engineering ability, you can you can put this easily in a car wash or in a valet parking, or maybe pay for some spy. Yeah, I don't know. Yeah, you can. That is possible. And at this moment, so many people ask if this is all about our investigation. And normally we say yes, it's all. But we always say too that for now, and at this moment we are working in another concept type of cars.
We never stop.
Yeah. But we don't have beautiful results for now. So thanks these people that for supporting our project, and thanks to you for being here and for the invitation to the conference. Thank you very much.
And thank you, Sheila and Claudio. Are there any questions?
Thank you. Well, first of all, thank you for this talk. I really liked it. First question, to contribute to the database, which kind of hardware do I need? I need just the picture to read from the CAN bus, or I need a CAN bus analyzer?
No. For the database? For the construction of the database?
To adding new features, like new frames.
No. This database is for every type of CAN message. So you can read with any tool and put the message there. It's for sharing.
Yeah, I know, but I want you to contribute with the cars I own, but the point is that I don't know which hardware I need to analyze.
For analyze, you can use this type of hardware that Sheila told you before. This one, let me show.
I got a spy, I guess.
¿Dónde me pasé?
No.
Sí.
Back.
1 second. Yeah. Here, this one. For example, this
one
is from Microchip, so it costs about $100.
Okay.
This one is open source, is hardware open source. Is about $13. Yeah. The same this one. You can do.
Yeah, no, I was late to the presentation. I missed this slide. That's
no problem. That's okay. No problem.
Okay, cool.
Thank you.
No problem.
Thank you for the presentation. Hi.
Thank you.
I have two questions, if we have time. So first one, you mentioned that one of the reasons why you had to design your own hardware is that because the software solutions, they're too slow in order to inject frames at the right phase. My question is, do you know if that's due to the implementation of those softwares and maybe there's something that can be done? Or is it an hardware problem rather than a software problem?
No, the problem that the software solution was not very fast, but you can modify this one, especially in the CAN utils. Yeah, you can modify that, but you need using like a Raspberry Pi or an Arduino,
of
and
course.
each module bigger than one. Yeah, this is one of the conditions. Yeah.
Okay. Thanks.
you're welcome.
Second question, I was wondering if you had any type of authentication for sending commands. Otherwise, if it's just relying on GSM, that can be turned against you. It's quite easy to spoof the cell and connect to that and use the backdoor.
Please, again.
Again.
Please repeat.
Okay, there is a GSM module,
Yeah.
which is receiving this.
Yeah.
I guess this GSM module is relying on the standard GSM network, which
Yeah.
means that it's quite easy with a rogue
Yeah,
base station.
that's right.
So I was wondering if you implemented any type of authentication for these messages.
We don't implement any type of authentication.
Is the
it's possible,
firmware
but we
the
don't.
firmware is open source of the?
The firmware, no.
Yeah.
The firmware,
Okay.
no.
Are you willing to open source
Yeah.
it?
I don't know.
I don't know.
Thank you.
If you want to maintain it, yes.
Let's talk about it.
All right, all right.
Thank you.
Yeah, sure. Sorry for our English. No?
I wanted to ask, right now and not later, because maybe someone else would be interested. About from forensics point of view, when you conduct some of those attacks, is there in the ECU, in the ECU, some logs
That's an
that?
excellent question. There is none.
Cool.
There is-
That's what I wanted to know.
Yeah.
Thank you.
No, there is no logs in the ECU modules, in any ECU modules. Yeah. Because it's difficult. There are so many frames in every moment that it's difficult to maintain the logs of that. Yeah. You need a lot of space. Yeah.
Could you also modify other ECUs, so from the gearbox or the air conditioning or so?
I'm sorry, I don't understand.
Could you modify other ECUs? So that
No.
you have a main ECU.
You can
and-
modify the ECU that is connected to the ODB2 port.
Okay.
Not in your car. You have not just one ECU. You have a lot of ECUs for different parts of the car, different modules or different segments of the car, but not are any of these exposed to the ODB2 port. Yeah. Maybe if you find the ECU in the car, you can search for the correct cable, yeah, and connect directly. Yeah, and you can send message any part of your car.
You could try some fuzzing on the CAN bus. Maybe you could deploy your airbags.
Yeah. Yeah. Be good people.
Any more questions?
Okay, thank
Thank
you.
you.
Sorry.
Not really my area of expertise, but if I remember correctly, the signals on the CAN bus, the legitimate ones, are being repeated quite frequently by the car. So if it be something like, I don't know, hitting the brakes, that is not just one frame that is being sent. There are multiple frames.
Yeah, that's true.
So if the legitimate signals are coming one after another, if you try to inject something that is in the other direction, wouldn't the car basically invalidate the injected signals?
I don't understand the question. Sorry.
So since the car is sending multiple repeated signals, would not invalidate the signals which are injected by your device?
Because we are injecting faster than the original signals. This is the condition. Yeah,
Okay,
this is
got
the
it.
condition. That is why we are not using software injector.
Yeah, we are overwriting every time the original CAN frame.
Oh, got it, thanks. And really cool. And thanks for doing it, especially for Hack in the Box.
Thank you. Right? Okay, guys, thank you very much. Have fun.
Thank you.